In example 4.10, we are asked to use the graph of f, which f is defined here to be the square root function. And we're going to use that to obtain the graph of g of x equals the square root of the 1/2 x. So they both are square roots in their own right, but g of x has a 1/2 multiplied by the x. So that means that my multiplier, I'm going to let a be equal to 1/2, which would then imply that the absolute value of a is also equal to 1/2. And that is a value that's less than 1. So I'm going to interpret this as a horizontal. In this case, by definition, it would be a horizontal stretch. And I'm stretching by a factor of 2. Now, the reason why I get 2 is because I'm always supposed to be taking the reciprocal of whatever my multiplier is. So here I'm dealing with 1/2, so the reciprocal of 1/2 is just 2. So we'll say horizontal stretch by 2. Let me go ahead and graph the square root function. There are several key points worth plotting: 0, 0, 1, 1, 4, 2, as well as 9, 3. And that's the graph of f. And I'd like to be able to graph g by applying this horizontal stretch by 2. So I need to start looking at some of the ordered pair. One of the ones that we mentioned was 0, 0. We said 1, 1. We also said 4, 2. And we'll stop there for the moment. And we're supposed to multiply each one of the x values by 2. So if I look at the first ordered pair, 0, 0 does not change. So I'll mark that point again. The second point, if I multiply the x value by 2, it will then be located at 2, 1. And then the point 4, 2, multiply its x value by 2, and it's now going to be located at 8, 2. And that should be enough to take me to the edge of the window if I continue the pattern, and that gives me the graph of g. So just like with example 4.9, when I execute the transformation of a horizontal stretch or shrink, I am only changing the x values. I am not doing anything to the y values whatsoever, and that's how we're able to create, in this case, the horizontal stretch by a factor of 2.